Okay, let me make this a little bit smaller and get this out of the way. We're really ready to kind of start physics now. I mean, we were doing some of the mathematics that surrounds physics. That kind of surrounds physics. Now we're ready to actually do some physics, and we're going to do kinematics in one dimension. And what kinematics means is motion. All right, it's the study of motion. It's not the study. We'll get into chapter 4 when we start pushing things around. Okay, what motion means. Okay, but for right now, we're going to say that things have already started moving. Okay, and that can be a little bit confusing to first timers to physics. And of course, I always have balls hanging around until today when I need the son of a gun. And all right, oh, here we go. Okay, so we're going to be looking at. Go ahead. I'm going to make this a little bit bigger. All right, so we're going to be looking at this type of thing where if I throw this ball in the air, okay, we're going to look at it once it leaves my hand. All right, so I'm applying a force on it, and then I kind of yank my hand away, and it continues in the as soon as it leaves my hand, okay, it leaves my hand. Now the only the only acceleration it's going to experience is gravity going down. We got to get that straight, okay? And we're going to be looking at things once they're already moving, okay? Once they're moving, that's what we're looking at. We're not looking at the force that gets it to move. We're looking at what happens when it's moving. All right, now the other thing. If we are in deep dark space or whatever, and something is moving, it's going to go to constant velocity. All right. One, and we'll talk about all this in a little while, but one of the things, if I drop something and I want to find its speed when it hits the ground, all right, this is a clue for some of the homework problems you might have, or a test question, or when we're doing problems in class, and it hits the ground, where it eventually comes to rest. It might seem like it comes to rest instantly, but actually it's got a velocity. It's got a speed coming down. It's not like it comes down and then this kind of stops and then sets in my hand. No, it hits my hand, right? So that's what they mean by the final velocity. All right, I'll get that later. Okay, so I think we're done with that portion. So let's go ahead and close this and let's look at some of the slides. All right, shall we? Okay, and then we'll look at some of the problems that might. Okay, deals with concepts that are needed to describe motion. Deals with the effect that forces it. So we're doing kinematics, not dynamics yet. Together they form what is known as mechanics. All right, displacement, initial position minus the final position. So you got this vector, this displacement vector x minus x naught gives me the displacement. Okay, all right, so that's the displacement. So if x is equal to x naught is 0.2, x this is 7 or 2 meters, and this total distance is 7 meters. 7 minus 2 gives me 5 meters. Okay, so far so good. That's displacement. Now then, we also, if we're going to go the other way, if I take if I'm going to say, okay, I'm going to go the other way. If I take 2 minus 7, I get negative 5 meters. That's going this way. All right, so if the final is 2, if I started here and ended here, then that's 2 meters minus 5 meters minus the 7 meters, okay? And that gives me negative 5 meters, okay? All right, that's displacement. So if I start here and I go negative 2, or if I start here and I go 5 minus negative 2, well, that'd be plus 2, so I'd go an extra 2. They drew that funny. Don't worry about that. All right, here's a big deal. Average speed, the difference between average speed and velocity, okay? Average speed is the total distance that you travel. And I want to make that, this is going to be a big deal point that I'm going to make right here, okay? Total distance traveled. I'm going to show you a couple examples. between total distance and displacement. Okay. All right. So let's just start with the. Let's start here with the with our ladybug here. Total distance versus displacement. This is big stuff. We're talking about speed and then we'll talk about speed and velocity. Okay, so here's an idea. Here's a big idea. All right, so if I've got total speed, so displacement versus distance, total distance. All right, let's do it with straight lines first. All right, let's say I go from point A to point B. Okay, and let's say that was, I traveled in centimeters. I traveled let's make it 500 meters. Let's say 1 centimeter is equal to 100 meters. So that's 500 meters. Okay. Then I traveled 1,000 meters this way. A 1,000 meters this way. Okay. And then I traveled 900 meters this way. Okay. All right. My total distance so far, so my total distance is 500 plus 1,000 plus 900, which gives me 2,400 meters. My displacement, on the other hand, is how the crow flies. I stopped here. I'm going to go back to my original position, and my displacement then is actually 850 meters. My resultant vector, r, is 150 meters. That's my displacement. Okay? If I run around a track, some of you are, let's say we got a completely circular track. Yes, I used to teach geometry in high school. I'm pretty good at drawing freehand circles. All right, so I start here. It's got a radius of 200 meters. This is a perfectly circular track of 200 meters. All right, so this isn't a regular track, right? All right, and I start here, and I go a whole half lap. A whole half a lap. Okay, so I started here, and I went a complete half circle. My total distance is, the circumference of this circle is 2 pi r. So the circumference is equal to 2 pi times 200, which is equal to 400 pi meters. I'm not going to compute out the pi. So if I go half the circumference is equal to 200 times pi. That's my total distance, which would be ballpark 630, 620 meters. My displacement, on the other hand, if I came from here over to here, my displacement, on the other hand, would be 400 meters. My change in position. I went from here to here. It's 400 meters. Big difference between the total distance and the displacement there. Those are two big examples. All right, this is video 1.